All right, this one is not challenging, but I do need you to focus your attention. We went over this in class, but again, if I sped through it, it's here so you can pause me and slow me down, Noah, not fast forward me. One, I want to look at, if I were to factor these, okay, two numbers when multiply together give me 6, but when add to give me 8 are 4, right? It's 4 and 4. So x plus 4 squared is the factored form of that trinomial, okay? And again, we found that magic number. So that magic number 1, two numbers when multiply together give me 1, but when added give me 2, or 1 and 1. So it would be x plus 1 and x plus 1, or just x plus 1 squared. Over here, two numbers that multiply together give me 81, but add together to give me negative 18. Those numbers are negative 9 and negative 9. So it would be x minus 9 and x minus 9, or just x minus 9 squared. Down here, two numbers will multiply together to give me 25, add together to give me negative 10. That would be negative 5 and negative 5. So x minus 5 and x minus 5, or just x minus 5 squared. Okay, that's a refresher. That's a warm-up. So what we did here is we know that these are also perfect square. These are perfect squared trinomials. Just like we said, square root of 49 is a perfect square, 7. These are perfect square trinomials, and that's very, very important for this lesson because this lesson is we are completing the square. That's how we are going to solve quadratic terms on this lesson. So last lesson, we solved by square roots. This lesson is we're going to solve quadratics by completing the square. So it's a little bit different here. So you've got to know what that perfect square trinomial is. All right. So for this, okay, stick with me here. What I want you to see is that this is a perfect square trinomial. And at this point, you should be able to recognize them. So two numbers will multiply together give me 2, but when add together give me 4, or 2 and 2. So that's x plus 2 squared equals 25. You with me? Okay. So now what do we do to solve? Well, I'm going to do inverse of operations. I'm going to take the whole square root of this term, because remember, square roots cancel out with squared, and it's talking about the whole of this binomial. So when I take the square root of this squared and the square root of this, I get x plus 2, because these guys cancel out, I'm left with x plus 2 equals plus or minus square root of 25, and I know that plus or minus square root of 25 is just 5. Okay? Now, I still need to solve for x. So, what I'm going to do here, you have two answers here. You have a positive 5 and you have a negative 5. So what I can do is I can say x plus 2 equals positive 5, x plus 2 equals negative 5, because there are two different solutions here. So I'm going to make two different equations because it's easier for me. So I get x equals minus 2 is 3, and x equals, when I subtract 2, I get negative 7. So my answers here are negative 7 and 3. Okay? All right, let's do another one. We're going to do all these examples together just like we did in class. So on here, I know that I have a perfect square. Two numbers will multiply together give me 36, but when added give me negative 12. Those numbers are x minus 6 squared. And I set that equal to 81. So now I'm going to take the square root of both of these. These guys cancel out, and I get x minus 6 equals plus or minus 9, because the square root of 81 is 9, so it's plus or minus 9. So I have two equations now. X minus 6 equals positive 9, x minus 6 equals negative 9. And now I just solve. Add 6, x equals 15, add 6, x equals negative 3. So the parabola is going to cross x at negative 3 and positive 15. All right? Let's do number 3. Give me just a sec. All right. Number 3. So here I recognize this perfect square. It's x minus 7 squared, because two numbers will multiply together give me 49, but add give me negative 14. Those numbers are negative 7, equals 4. So now I'm going to take the square root and the square root. These guys cancel out. X minus 7 equals plus or minus 2. So now I form two different equations. X minus 7 equals positive 2. X minus 7 equals negative 2. Add 7, and I get x equals 9. Add 7, and I get x equals 5. And remember, it's a solution, so the parabola crosses the x-axis at 5 and 9. All right, let's do this last one together. Perfect square is going to be x plus 3 squared equals 1. Two numbers will multiply together, give me 9, but add to give me 6 or 3. I'm going to take the square root because I'm going to undo that, and I'm left with x plus 3 equals plus or minus 1. I set up my two equations. X plus 3 equals 1. X plus 3 equals negative 1. Subtract 3, and I get x equals negative 2. Subtract 3, and I get x equals negative 4. So that parabola crosses at negative 4 and negative 2. Okay, so hopefully you got that. If not, slow me down so you can go back. All right, now look at these. Those were kind of easy. They were easy to recognize, right? I can recognize a perfect square, recognize it, and recognize it. But down here, what happens if you don't have a perfect square? We're going to make it. We're going to make it fit that perfect square. So when you don't have a perfect square, we create one, and this is called completing the square. So I've written down these steps for you to write. So these steps are written down for you. So we're going to rewrite it at this term. Notice quadratic and linear term are on the left. Constant term is on the right. So here I would say x squared plus 8x equals negative 7. My constant term is on the right. And so I had to subtract 7 on both sides. So in order for me to complete this square, what I'm going to do is I'm going to look at this value here. So I'm asking myself, what number does this have to be for me to create this perfect square? And here's how you find it. You divide this. So take half of b, so we divide it, which is 4, and then we square it. So 8 divided by 2 is 4, and then we square it, which is 16. Okay? 8 divided by 2 squared. So take half of b and square it. Now, because I'm adding 16 to this side, equations are, you got to have equality, right? Equations are equality. So if you add 16 on this side, buddy, you better add 16 on this side or equality doesn't stand true. So you can do anything you want to an equation, you just got to do it equally. So if I add 16 over here, I got to add 16 over here. Now, I've created my perfect square. So x, two numbers will multiply together and give me 16, but add together give me 8. That number's 4. And negative 7 and 16 is 9. So that's where I am here. And now I'm just going to repeat the process that I did above. Take the square root. Those guys cancel out. X plus 4 equals plus or minus 3. I create my two equations. X plus 4 equals 3. X plus 4 equals negative 3. Subtract 4. I get x equals negative 1. Subtract 4 and I get x equals negative 7. Not forgetting to put it in bracket form. So it crosses the x-axis at negative 7 and negative 1. All right, let's do another example together. A couple more examples together. Let's take a look down here at number 7. Okay, so I still want to fit that form, quadratic and linear term on the left, constant term on the right. So I'm going to bring this guy over. So I get x squared, I'm going to subtract 18x. So I get subtract 18x, and then I subtract 71 on both sides, and I get negative 80. So here's where I am. And all I've done, give me 5 minutes. So all I've done is I've manipulated that. So now I'm going to create my perfect square. So to do that, it's what two numbers, how do I get that perfect square? Well, I divide by 2, negative 9 divided by 2, or negative 18 divided by 2 is negative 9. Squared is 81. So that becomes plus 81. And whatever I do to one side, I do to the other side. So now I've created this perfect square. Two numbers will multiply together to give me 81, but add together to give me negative 18. Those numbers are negative 9. And then I do it over here to get 1. I take the square root of both of those, and I get x minus 9 equals plus or minus 1. And you know how to create those two. I just want to make sure you understand how to complete the square. All right. Let's look at those irrational ones. Nothing's different. It's just you got to simplify your radical terms. So let's take it, it's not too difficult, but let's take a look at number 12. So here, again, a quadratic term and linear term on the left, constant term on the right. So I get that negative 6x, so I get x squared minus 6x. I want this negative 2 on the other side, which means I add it, and that equals negative 1. So I manipulated my equation. Now I'm going to create my perfect square. So I divide negative 6 divided by 2 squared. Negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9. If you add positive 9 here, you add positive 9 on the other side, it creates that equality. So now I'm creating x minus 3 squared equals 8. Take the square root of both of those, and I get x minus 3 equals plus or minus the square root of 8. Remember to simplify the square roots of 8. So square roots of 8 is the same thing as square root of 4 and square root of 2. Square root of 4 is 2. So I can say x minus 3 equals 2 square roots of 2, and x minus 3 equals negative 2 square roots of 2. So when I find x is simply 3 plus 2 square roots of 2, and x over here is 3 minus 2 square roots of 2. So x equals, when I get here, 3 plus 2 square roots of 2 and 3 minus 2 square roots of 2. Usually what you do when you have an improper one is it's quite easy. Actually, you can do 3 plus or minus 2 square roots of 2. So either way is okay. This, I've separated them. Here, it's just 1, 3 plus 2 square roots of 3, 3 minus 2 square roots of 2. So either way is going to be acceptable. If I went over fast on that one, just come in and see me. But good luck.